Stop re-leveling your 3D printer bed. You've been re-leveling your bed before every single print, and the first layer still won't stick evenly. But the real problem isn't that your bed is unlevel. It's that your nozzle path isn't parallel to it, and once you fix that one idea, the endless re-leveling stops forever. Leveling vs. Tramming. The key difference. Bed leveling is about gravity level, but that's the wrong target. Your nozzle needs to stay at a constant distance from the bed across the entire surface, which is called tramming. Tramming means the nozzle path is parallel to the bed. Even a perfectly level bed prints garbage if the Gantry sits lower on one side and higher on the other, tilting your nozzle path. Every fix after this one either tightens mechanical play that causes drift, confirms your Z0 repeatable, or physically squares the Gantry. They all serve one goal: keeping nozzle to bed distance consistent. Once you understand that first layer failures are consistency problems, not a leveling problem, you stop re-leveling before every print and start fixing the root cause instead. Eliminate mechanical play in the bed. If your bed has loose carriage screws, worn wheels, or overly soft leveling springs, the bed shifts every time the printer moves. You level it Monday and it drifts by Wednesday. You re-level the bed before every single print, because it's physically moving during prints or between them, instantly undoing your careful work. Before touching a single leveling knob, grab the bed with both hands and push it side to side, front to back, and up and down. Any wobble or give means mechanical parts need tightening. Snug the eccentric nuts on your bed carriage wheels. These small oval nuts hold the wheels against the rail and prevent lateral play. Tighten them carefully so the bed slides smooth, not stiff. If the leveling springs under the bed are mushy and compress too easily, swap them for stiffer springs rated at 10 to 15 newtons per millimeter or add silicone spacers to keep the bed stable over time. Make Z0 repeatable and trustworthy. If your printer's idea of Z0, where the nozzle actually meets the bed, shifts between prints, no leveling method helps. First layer is too high one day and gouging the next. You level the bed, run a print, and halfway through something feels off. The nozzle is suddenly closer or farther than yesterday, trashing the first layer. If you have an ABL probe like a BL touch or inductive sensor, clean both the nozzle and probe tip with isopropyl alcohol and melt the probe rock solid. Any flex or dried filament kills repeatability. Run a test G-code that probes the same bed spot 10 times and check if the Z-height reading varies by more than 0.1 millimeters. If it does, the probe needs cleaning or your mount is loose. For manual leveling, use a feeler gauge or paper at exactly 200 degrees Celsius nozzle temperature every time. Heat. Use the same paper thickness and mark your starting point, so re-leveling always uses identical conditions. Where the gantry to the bed. On a 2Z motor printer, if one side of the gantry sits even 1 millimeter lower than the other, the nozzle is closer to the bed on that entire side across every print. Leveling 4 corners can't fix a tilted gantry. You level the bed perfectly, but first layer adhesion is amazing on one side and terrible on the other. That's the telltale sign of gantry tilt, not a leveling problem. Power off the printer and loosen the gantry slightly. Then hand crank both Z motor lead screws at the same pace while measuring the distance from the X-rail to the printer frame on both ends with a ruler. Get both sides to within 0.5 millimeters of each other by adjusting the lead screw positions. Use a digital caliper for precision, because even 1 millimeter of tilt ruins the first layer. Some printers like the Prusa MK3s have a built-in first-layer calibration routine that motors the Z-screws to auto-level the gantry. Run it after any mechanical work to confirm the gantry is square. Get the gap right. The Squish test. Even a perfectly trammed bed prints badly if the nozzle-to-bed gap is wrong, too high and filament won't stick, too low and it smears, clogs the nozzle, and scars the bed surface. Leveling 4 corners tells you the bed is flat, but it doesn't tell you if that distance is right for adhesion. You have to actually watch the filament being laid down. Print a simple first layer test, a square outline or series of lines, and watch how the filament lays down for the first 30 seconds before you walk away. You want to see lines that are lightly squished together with no gaps between them and no ridges. That's the sweet spot for adhesion and surface quality. If the gap is wrong, live adjust the Z offset during the test in tiny 0.02 to 0.05 mm steps using the printer menu or Octoprint. Each nudge changes how much the nozzle squishes the plastic. Stop chasing the paper drag myth. Your real target is the first layer that actually sticks and looks clean, and you find it by watching and tuning, not by guesswork. The payoff: rare leveling, not constant. If you're re-leveling before every print, that's a symptom screaming that loose hardware, a flaky sensor, or a tilted gantry hasn't been fixed yet. You're treating the symptom, not the cause. Once your bed is mechanically solid, your Z0 is repeatable, and your gantry is square, your first layer stays dialed in for 20, 30, or 50 prints. You level rarely, not constantly. After you fix the root cause, re-level the bed maybe once a month during routine maintenance, or only if you move the printer or replace a part. First layer failures aren't a leveling problem. They're a consistency problem, and consistency comes from removing slop, trusting your Z0, and squaring the gantry once and for all. Your first layer stays dialed in when you stop chasing leveling and fix the consistency problems underneath. Tight hardware, repeatable Z0, and a square gantry. Before your next print, rock your bed with both hands to check for wobble and snug any loose screws. Then run one first layer squish test to dial in the gap. If you found this frustration saver useful, subscribe for more 3D printer deep dives that cut through the beginner myths.